So, good day everyone. My name is Herman G. Benmoro Jr. and today we're talking about other elements and properties of a triangle. So, this topic is under the plane and spherical trigonometry class. So the first one is the area of a triangle. What is the area of a triangle? A total region that is enclosed by three sides of any particular triangle. So there are many kind of formula that can get the area of a triangle. One of the examples is the base and the altitude, where area is 1/2 base times height, where A is equal to area and B is equal to base and H is equal to height. So second is the given sides A and B and included angle theta. So to get the area, here's the formula. Area is equal to 1/2 AB sine theta, where A and B is the sides and the big letter A is the area and the sine theta is the included angle between two sides. The third one is the Heron's formula, where given three sides A, B, and C, where A, B, and C is the given sides. Next is you can get the area by square root the S times S minus A times S minus B times S minus C, where S is the semi-perimeter. You can get the semi-perimeter by adding the three sides and then divided by 2. So under the condition of Heron's formula, given three sides, you can use cosine law by using this three formula. If you're finding A, you can use A squared is equal to B squared plus C squared minus 2BC cos angle A. You can get the angle A. Then if you're finding angle B, you can use this formula. B squared is equal to A squared plus C squared minus 2AC cos angle B. So you can get the angle B. Then if you're finding angle C, you can use this last formula. So C squared is equal to A squared plus B squared, then minus 2AB, then times cos angle C. So you can also find the three sides by square root this A, then square root this also. So you can get the sides. Then to find the area, you can also use this cosine law. Cosine law, and then use it in two sides and one included angle. And lastly is the sine law, where A over sine A is equal to B over sine B equal to C over sine C. You can get if you're finding either the sides or the angle, you can use sine law formula. So you can use this if you're finding, for example, if you're finding A and you're given sine A and side B and sine angle B, you can get the side A. So here are also the example of how to use sine law. If you're given perimeter and three angles, you can use this formula. So you can let this one to key, and key is also perimeter over sine A plus sine B plus sine C. So you can get the key, and noted that key is equal to either these three. So if for example, if you're finding side A, you can use key is equal to A over sine A. Then A is equal to key times sine A. So you can get the sine A. So that's it. The second one is the median of a triangle. So what is a median of a triangle? So a median of a triangle is a line drawn from one vertex to the midpoint of its opposite side. The medians of a triangle intersect at a common point called centroid of a triangle. So from our drawing here, from vertex A, a line drawn from vertex A to side A, then vertex B to side B, then vertex C to side C. Then the intersection here at the center called centroid. So properties of a median triangle. So first is every triangle has three medians. Second is those medians meet at a single point called centroid. Next is each median of a triangle divides a triangle into two smaller triangles which have equal area. So from our drawing here, if we draw a median from vertex A to side A, we can form two triangles, which is vertex C to vertex A, then to side A, then vertex A to vertex C, then side A. You can form two triangles. In fact, if in three medians, you can form 6 triangles which have equal area. So altitude of a triangle. So what is the altitude of a triangle? A line drawn from one vertex perpendicular to its opposite side. The altitude of a triangle intersect at a point called orthocenter of a triangle. Properties of altitude of a triangle. So first is every triangle has three altitude, one from each vertex. So the altitude always makes perpendicular to its opposite side. So in our drawing here, vertex A to opposite side A, it makes the perpendicular or 90-degree angle. So the 90-degree angle located here in side A. Next is the altitude. The altitude is the shortest distance from the vertex to its opposite side. Next is the three altitude always meet at a single point called orthocenter. So altitude may lie outside or inside a triangle. The last one is angle bisector of a triangle. So what is the angle bisector? A line drawn from one vertex to the opposite side bisecting the included angle. The angle bisector of a triangle intersect at a point called in center of a triangle. So the center here called in center, then the line here called the angle bisector, which separate the angle into two equal angle. The properties of angle bisector of a triangle. So first, an angle bisector divides an angle into two equal parts. So from angle of the vertex A is divided by the bisector of this line from A, side A. Side A. Then same as vertex C and B. Next is in a triangle, it divides the opposite side into the ratio of measure of the other two sides. So just like I said, it divides by the angle of vertex A is divided by the side A. Then also it divides also the measure of the opposite side of the vertex. Next is the from the center of this triangle in angle bisector is called in center. Then, these three lines here called the bisector. This one, this, also this one. This one. Okay. That is called the bisector. So today we're going to give an example of the area where AB times sine C or sine theta. Okay. So here is the example. The sides of the triangle are 50 meter and 60 meter. The angle included between the sides is 30 degrees. Find the area. So in triangle ABC, or let the triangle ABC B, C, and side A, side C, and side B. So let 50 is equal to side A, and let 60, this is by the way, this is meter, so meter is equal to side B. So we're gonna use the area is equal to 1/2 AB times sine theta. So it is said that the angle included between the sides, so A and B, so the angle between that is C. So angle C. So let 30 degrees is equal to angle C. So we're going to find the area. So we're gonna use the area is equal to 1/2 AB times theta. So area is equal to 1/2 AB times sine theta. So 1/2 50 meter times 60 meter sine 30 degrees. So 50 times 60 is equal to 3,000 meter. Times divided by 2 is equal to 150 meter times sine 30. So 150 meter, 1,500 meter times sine 30. Oh, sorry. So 1,500 times sine 30 is equal to 750 meter. So that's it. Sorry, my mistakes. So 150 meter squared, that is the area of this problem. And the second example is the Heron's formula. This is the example of Heron's formula. So the sides of an angle are 195, 157, and 210 respectively. What is the area? So first we're going to find the semi-perimeter. But first we're going to let 195 to A. So A is equal to 195, B is equal to 157, and C is equal to 210. So we're going to find the semi-perimeter. So semi-perimeter is equal to A plus B plus C over C. So sorry. This is 2. So 195 plus 157 plus 210 is equal to 562. Divided by 2, 281. So our semi-perimeter is 281 unit. Now we're going to use the Heron's formula. So the Heron's formula is area is equal to square root of S, or the same perimeter, times S minus A times S minus B times S minus C. So area, so by using this area, we're going to get the area of this problem. So we're gonna input this in our calculator. So 281 square root of 281 times 281 minus 195 times 281 minus 557 times 281 minus 210. So the area is 14,586.21 unit squared. So that's how you can solve the Heron's formula problem. So the last example consists of three elements of a triangle. So the problem is three sides of a triangle are 38 meter, 20 meter, and 26 meter respectively. Find the altitude of the median, median, and the bisector. So we're gonna find the three altitude, median, and bisector. So first, we're going to analyze the problem. So we have the given of 38 meter, 20 meter, and 26 meter respectively. So let A is equal to 38 meter. Then let B is equal to 20 meter, and let C is equal to 26 meter. So we're going to erase this so we can have a bigger space to solve this. So first we're going to get the angle of this side. So first we're gonna use cosine law. So cosine law of this side A is A squared plus B squared, B squared plus B A squared is equal to B squared plus C squared minus 2BC cos A. So we're going to derive this one so you can easily get the other angle. So first is we're gonna this B squared plus C squared, we're gonna transfer it to this side. So A squared minus B squared minus C squared is equal to negative 2BC cos A. Then times both sides by negative 1 and negative 1. So cancel. So negative 1 times A squared, so negative A squared. Negative 1 times negative B squared, so positive B squared. Then same this one, so plus C squared is equal to 2BC cos A. Then divide both sides by 2BC. So this one, this 2, so BC, then BC, 2BC. So cancel. So cos A is equal to negative A squared plus B squared plus C squared over 2BC. Then transfer the cos to other side. So A is equal to cos -1 negative A squared plus B squared plus C squared over 2BC. So that is the derivation of how to get the angle by using cosine law. So eraser. So this is how you can get the angle. So A is equal to r cos times negative A squared plus B squared plus C squared over 2BC. Next is how we're gonna get the angle A. So A, so cosine r cos times 38 squared negative plus 20 squared plus 26 squared over 2 20 times 20 times 26. So we're gonna use calculator to make it quick to answer the angle A. So r cos over negative 38 squared plus 20 squared plus 26 squared over 2 20 times 26. So the angle A is 110.72 degrees. So that is the angle A. So we're gonna use this formula, but we're gonna change the letters here. So angle A, so our angle A is equal to 110.72 degrees. So notice that if we're going to get the angle, its opposite side we're going to be negative, then the other two sides we're going to be positive. Then over to the other two sides, so BC. So if we're going to get the angle B, so angle B is angle B. So angle A is then cos r cos -1. Then so like I said, if we're going to get the angle, its opposite side we're going to be negative. So negative B squared, the other two sides we're going to be positive. So A squared plus B squared, sorry, this is going to be C squared over 2AC. That's how we're going to, then we're going to apply this, how we're going to get the B to C. So we're going to get the B. So B, angle B is equal to cos r cos negative 20 squared plus 38 squared plus 26 squared over 2 times 38 times 26. So by using this, we're finally going to get the angle B. So r cos negative 20 squared plus 38 squared plus 26 squared over 2 times 38 times 26. So the angle B is The angle B is 29.48. Oh, 49 degrees. So, angle B is 28, oh, sorry, 29.49. Next, angle C. Notice that we have angle A and angle B. So if in triangle, the angle of a triangle is the sum of the three vertex angle vertex we call is 180. So if we can easily get the angle C by using this one. By using angle A plus angle B plus angle C is equal to 180, because the sum of the triangle of a triangle is 180. So angle, we're going to get the angle C. So angle C is equal to 180 minus A, angle A plus angle B. So 180 minus times angle A, 110.72 plus 29.49. So the angle C is 39.79. So we have gathered all of the sides and angle of a triangle. Now we're going to solve the altitude. So now we're going to get the altitude. So first we're going to get the angle B, since from upper. So our side C is 26 meter and side B is 20 meter and side A is 38. Now we're going to get the altitude, or the perpendicular of vertex B. So from vertex B we have 26, then angle A. Now we're going to get this altitude by using trigonometric function. So sine A, so sine because it opposite over hypotenuse. So sine A is equal to opposite HB over 26 meter. Now our sine A is 110.72. Now to get the HB, we're going to get rid of 26. So we're going to transfer this 26 to other side. So times this 2 by 26 meter. Cancel. Then 26 times sine 110 or 110.72. So sine 110.72 times 26. So the altitude of vertex B is equal to 24.32. meter. So that is the altitude of B. Next, we're going to get the altitude of angle A. So this one. So HB is equal to 24. So we're going to replace this one. So we have the altitude here. So notice that the angle AB, we're going to get this point here by D. So angle ABD, we have 26 meter and the angle B. So opposite, we're going to get the sine opposite over hypotenuse. So sine B is equal to opposite. So this HA over 26 meter. Same process from using we're finding the altitude of angle B. So times this both sides by 26, so cancel. So 26. So our sine B is 29.49. So 29.49. So 26 times 29.49. So altitude of vertex A is equal to 12.8 meter. So that is the altitude of vertex A. Next, we're going to get the altitude of vertex C. So HA is equal to 12.80 meter. Now we're going to get the altitude of vertex C. We can use. Now we're going to get the altitude of angle C. So you can use both sides of a triangle, either B or an A. So we're going to get rid of this point B because we're going to get the altitude of angle C. Now, you sine A over the opposite over hypotenuse. So HC, or the height of C, over 20. Then, same process, cancel this 20 by times it by 20 both sides. So cancel. So our 20 is our sine A is 110.72. So 20 times sine 110.72, 18.70. So sine height of C is equal to 18.71 meter. So that's how you get the three altitude of a triangle in a given problem. And now we're going to find the median of the problem. So first, we have the given side, then we also solve the angle of those three sides. So first, we're going to find the angle, the median of angle A. So first, we're going to divide its opposite side. So 38 divided by 2 is 19. So 19 here, and then 19 here. Then we're going to use the left side of a triangle, or left side of the median. This one. Then, since we have the angle B, our angle B is 29.49. So we're going to use cosine law. So cosine law of angle B, then let angle B median A. So 19 A squared, median A squared, so is equal to 19 squared plus 26 squared minus 2 times 19 times 26 cos 29.49 square root, then square root. Our median A is equal to, so we're going to use our calculator. So square root of 19 squared plus 26 squared minus 2 times 19 times 26 times cos 29.49. So our median A is 13.30 meter. Don't forget the units of the value. So our median A is equal to 13.30. And now we're going to solve the median B. So median B, since its opposite side is 20, we're going to divide that. So 20 divided by 2 is 10, then 10 here. So since we have angle C is 39.79 degrees. So we're going to use cosine law, just like I use to median A. So let B is equal to median B. So median B. So its opposite, its sides is opposite. I'm sorry. So let median C is equal to median B. Let side C is equal to median B. So it's the sides between this included angle is 38 and 10. So 38 squared plus 10 squared is equal minus 2 times 38 times 10 cos 39.79 degrees. So we're gonna use our calculator. This squared, then squared here, square root here, then square root also here. So 38 squared, square root of square root of 38 squared plus 10 squared minus 2 times 38 squared, oh no, times 38 times 10 times cos 39.79. So our median B is equal to 30.98 meter. So our median B is equal to 30.98. So we're going to get the median C. So from angle C to its opposite side, this line here is the median. So since it's median, this 26 is divided. We're going to divide this 26 by 2. So 26 divided by 2 is 13. Now we can either use this angle or this angle. So I'm gonna use the angle downs. So this angle here is 29.49. So since we have 13 included angle between two sides, and then the other side 38 meter. Oh, sorry. So this is meter. Always put units after the value, so you won't be confused what is the units. Next, we're going to get the median of angle C by using cosine law. So median, so let B is equal to median C. So median C is equal to 13. I'll square this. So 13 squared plus 38 squared minus 2 times 13 times 38 times cos 29.49. So square root this one, then square root this. So square root of 13 squared plus 38 squared minus 2 times 13 times 38 times cos 29.49. So our median C is equal to 27.44. So our median C is equal to 27.44 meter. So like I said, always put the units if it's given. So if not given, the units are not given, use units or unit squared if you're going to find the area. So this is the median. So this is the median. Now the next is we're going to find the angle bisector. And lastly, we're going to find the angle bisector. Since we solved the altitude and the median of the problem, now we're going to find this problem, which is the angle bisector. Now we're going to find the angle bisector of A. So to solve this, we're going to divide the angle bisector of A. So 110.72 divided by 2 is 55.36. Then angle at our angle B is 29.49. Now we're going to find this angle. To find that, we're going to add this angle, then minus it by 180. So 29.49 plus 55.36. Then we're going to divide the we're going to minus 180 to sum of this angle. 180 minus the sum of this angle. So this is 95.15. Now, since we have the angle of this the angle of this tree. Now we're going to use the sine law. So sine law is A over sine A is equal to B sine over sine B, then C over sine C. Now, since we're going to use this one, so let this point here to D. So we're gonna use 26 over its opposite angle is 95.15. So sine 95.15 is equal to this opposite side. So angle B, its opposite side, this median, this angle bisector. So they're going to use angle bisector A over sine 29.49. Then we're gonna divide this sine 29.49. So cancel this one, then times here 29.49. See? So sine sine 29.49 times 26 over sine 95.15. So our angle bisector of angle A is 12.85 meter. Oh no, degree. Sorry, this is meter. So our angle bisector of angle A is 12.85 meter. And now we're going to find the angle bisector of angle B. So to solve it, we're going to divide the angle B by 2. So our angle B is 29.49 divided by 2 is 14.745. So 14.745. Then our angle C is already given. This is 39.79, and we're going to find this angle. So let this point D. So angle BCD. Then to find this angle D, we're going to sum this angle, then divide minus it by 180. So 180 minus 14.745 minus 39.79. So our angle D is 125. Oh no. So our angle D is 125.465 degrees. So next we're going to use the sine law. So (38) over sine 125. So in case you're doubting this angle, we're going to add this. So if it is equal to 180, so 125.465 plus 39.79 plus 14.745. So it is equal to 180. So now we're going back to where we are. So 38, its opposite angle is 125.465 is equal to angle bisector B over sine 39.79. So divide times this both side by sine 39.79. So cancel this. So sine 39.79 times 38 over sine 125.465. So our angle bisector B is equal to 29.85 or 86. So our angle bisector B is equal to 29.86 meter. And now we're going to find the angle bisector C. So angle C is angle A, P. Now we're going to draw a line here. This means that it is the angle bisector C. So since we have a given angle B, or we solve it. So our angle B is 29.49. Then our angle C is 39.79. So we're going to divide it by 2 since it is angle bisector. So 39.79 divided by 2 is equal to 19.895. Then our opposite side A is 38. Then our opposite side C is 26. So since it is opposite side C, then no, sorry. So we're going to find this angle. So to find that, we're going to sum this angle, then divide minus it by 180. So 19.895 plus 29.49. So it's equal to 49.385. Then divide minus it by 180. 180 minus the sum of this angle. So this angle here is 130.615. So now we're going to use sine law. So 30. We're going to label this angle bisector by A, big letter A, C. So this means that angle bisector C. So angle bisector C, its opposite angle is 29.49. So sine 29.49 is equal to 38 over its opposite angle. So its opposite angle is 130.615. So sine 130.615. So divide this minus this times this both side by sine 29.49. So you can cancel this one or transfer this sine 29.49 to other side. So angle bisector is equal to sine 29.49 times 38 over sine 130.615. So our angle bisector C is equal to sine 29.49 times 38 over sine 130.615. So our angle bisector C is equal to 24.64 meter. So That's how you solve the angle bisector. So that's it. The problem is solved since since we solved the altitude, median, and the angle bisector. So that's it. Thank you.